In this lecture, we learn how to solve systems of linear equations. What do we mean by systems of linear equations? System of linear equation, that means more than one equation, more than one linear equation, and they are solved simultaneously. The general form for linear equations is a1 x1 plus a2 x2 plus up to a sub n x sub n equals some constant b. So here x1 means one variable and x2 another variable, xn other variable. So we have variables, different variables, but they have power 1. That's why they are linear. This type of equations is linear. Now, if you have more than one equation, we may have one of three cases, I mean in terms of the solutions. So we have the first case, only one solution in terms of solutions. One solution if we graph the functions or the equations and the graphs meet at one point. In this case, we only have one solution, and the system is called consistent. And the second case is if they don't meet, and in that case no solution. That means the two lines do not meet at any point. That means they are parallel. I should do it this way. Okay, so the second case, no solution if they are parallel, because we know that solution means the points of intersection, or the points where the lines or graphs of equations meet. Now, so they don't meet, that means we don't have solution, and in this case we call the system inconsistent. Now, the third case is that we have infinitely many solutions, and that happens if the two equations agree at all points. So they agree at all points. So the two lines, for example, coincide. The two lines coincide. That means the points in common are infinite, all the points. In this case, we call the system, we still call it consistent because we have solutions. So if the system has solutions, then we call it consistent. If it doesn't have solutions, then it's inconsistent. Now let's take some examples of systems consistent and inconsistent. For example, one solution, for example, if we have x, if this line represents x plus y equals -2, and the other line represents 2x minus y equals 2. If we solve these equations, or if we graph them, we get something similar to this graph, and they meet at one point. This is graphically how to show that there is one solution, or they are consistent. Now, for the second case, when we have no solutions, we may call this 3x. This is just an example. 3x plus 2y equals 3, and the other one 3x plus 2y equals -4. And as we can see, the only difference is the constant on the right hand side, but the left hand side is the same. That means the two lines are parallel. They don't meet. That means there's no solution. And infinitely many solutions if, for example, one equation is x minus y equals -3, and the other one is 2x minus 2y equals -6. And as we can see, the second equation can be obtained from the first equation by multiplying the first equation by 2. And that means they represent the same equation, because we can divide the second equation by 2 and we get the first equation. So the two lines are the same. In this case, we have infinitely many solutions because they meet at infinitely many points. Now, how to solve systems algebraically? How to solve systems of linear equations algebraically. We have different methods, but the most important ones here are the substitution method and the elimination method. Substitution method. Let me show you the substitution method by solving one example. So let's solve the following example. We have x plus y equals -2. This is the first equation. And 2x minus y equals 2. This is the second equation. And actually they are here. We found the solution that they meet at one point. That means we have one solution. But we want to solve this system using substitution method. Now, how to solve this? Substitution method is a method based on writing one variable in terms of the other variables, and then substituting that variable in the other equation that we didn't use. For example, we may solve the first equation for y. So let's solve the first equation for y. Y is equal to -x minus 2. Now we call this equation star, and then we plug star in the second equation. That gives 2x minus y. Y is -x minus 2 equals 2, and then we solve. We get one equation of one variable. So plus x plus 2 equals 2, and then 3x equals, when we bring this to the right hand side, it becomes -2, and we have plus 2 is 0. Divide by 3 both sides, you get x equals 0. Now if x equals 0, then what is the value of y? We just plug this into star to get the value of y. Y equals -2. So the solution is 0, -2. It's an ordered pair because we have two variables, x and y. So since we got one solution, which is the ordered pair 0, -2, the solution is consistent. We have only one solution, and the solution is consistent, or the system is consistent. Now, this method is called substitution method. Now, the second method is called elimination method, and this method is based on the step that we eliminate one variable, either x or y, by adding the two equations, or subtracting them, or multiplying by some value and adding that to the other equation. So we have elimination method. Let's solve the same problem using elimination method. We have x plus y equals -2. This is equation 1. And 2x minus y equals 2. This is equation 2. Let's solve this using elimination method. So we want to eliminate either x or y, but it's clear that it's easier to eliminate y because y here is positive, here negative. If we add the two equations, we add x to 2x, this is 3x, y to negative y, this is 0, -2 to +2, this is 0, and then we solve for x is 0. And after finding x, we can substitute in any of the two equations to find y. Let's substitute into 1. So we have x0 plus y equals -2. That means y equals -2. So the solution is 0 and -2. And as you can see, we got the same result as the result that we obtained it using the substitution method. So these are the most common methods of solving linear systems. Now let's take some other examples. So here in this example, we solved an equation or system that has one solution and that's consistent. Now let's try to solve other type of systems. 3x minus 2y equals 4. This is equation 1. And negative 6x plus 4y equals 7. This is the second equation. Now to solve this, we can think of the elimination method. Maybe it's easier to solve using elimination method because if we want to use substitution method, then we need to solve for example, y or for x, but in that case we get fractions. So let's use the elimination method. So we want to eliminate either x or y. Now what should we eliminate? Now as you can see, if we multiply the first equation by 2 and then add it to the second equation, we can eliminate x. So let's multiply the first equation by 2. That gives 6x minus 4y equals 8. And the second one is negative 6x plus 4y equals 7. Then we add the two equations. This is 0. This is 0 as well. This is 15. So 0 equals 15. This is impossible. This is impossible or false statement. And that means there is no solution. If we get similar answer, two sides not equal or two numbers not equal, and we have equality between them, that means there's no solution. What does that mean graphically? Graphically, that means they are parallel to each other. So if we graph these two equations, so let's graph the first one. Let me graph it here. We want to graph the two equations here. This is x, this is y. Now in order to graph the first equation is 3x minus 2y equals 4. In order to graph this, we can take x equals 0 and y equals 0 and then find the 2 points, ordered pairs. When x equals 0, y equals negative 2. When y equals 0, x equals 4/3. So the 2 points are 0, negative 2, and 4/3 and 0. So 0, negative 2, this point here, and 4/3 and 0 here. So when we graph this, we get this line. So this is 3x minus 2y equals 4. Now let's graph the other line. The other equation is negative 6x plus 4y equals 7. We make a table. We have x and y, 0, 0. When x is 0, y equals 7/4. And when y equals 0, x equals negative 7/4. So the 2 points are 0, 7/4, and negative 7/4 and 0. Now when we graph this on the same xy plane, we get 0 and 7/4. So 0, 7/4, it's a point here, less than 2. And the other point, negative 7/4 here, negative 7/4. And then we graph with another line. And as we can see, the two lines are parallel, and that means there's no solution. So the solution here is the system is inconsistent, and there's no solution. Now let's do another problem of a different system. For example, if we want to solve 8x minus 2y equals negative 4 and negative 4x plus y equals 2. Now for this problem, maybe we can use substitution method because it's easy to use substitution method because we have y here with coefficient 1, so we can solve 2 for y. I mean, we are using substitution method. So if we solve the second equation for y, we get y equals plus 4x plus 2. Now this is star. I brought this negative 4x to the right hand side, it becomes positive. So this is the equation star. Now since we obtained this from the second equation, we plug star into 1. So 1 is 8x minus 2 times y. Y is 4x plus 2. Now this is equal to negative 4. Now we have 8x minus 4 equals negative 4. This is 0 minus 4 equals negative 4. That means negative 4 equals negative 4. So the left hand side is equal to the right hand side. So this is true for all values, for all x and y. So that means we have infinitely many solutions. So if we get two sides of the equation are equal, two numbers or the same number on the left hand side and the right hand side, negative 4 equals negative 4, 0 equals 0, and such statements, that means we have infinitely many solutions. And this means that the two lines are coincide. They meet everywhere. So the graph looks like this, and we have this represent both 8x minus 2y equals negative 4 and negative 4x plus y equals 2, because if you substitute, for example, x equals 0, you get from the first one, you get y equals 2. If you substitute x equals 0 from the second one, you get 2. So you get same values for all values of x and all values of y. So that means that we have infinitely many solutions. Now, how to express the solutions? How to write the solution? To write a general form for the solution. Solution set. Now, to write it, we use an ordered pair and we determine x first. Now, if we determine x, then we can use star to represent y in terms of x. So y is 4x plus 2. This is x, this is y. So we have an equation of one variable x. Give me any value of x, I can give you an ordered pair or a solution. So for example, if x equals 0, then we get 0, 2. If x equals 1, the solution is 1, 6, and so on. So we have infinitely many solutions. The last example is 3 by 3 system. If we want to solve the system 3x plus 9y plus 6z equals 3, this is the first equation. 2x plus y minus z equals 2, this is the second equation. And x plus y plus z equals 2, this is the third equation. Now we want to solve this system. We can use elimination method. It's better to use elimination method for this system and in general for 3 by 3 systems. So how can we solve this type of problems? We have 3 variables, so we try to reduce number of variables into 2. Reduce number of variables to 2. Now how to do that? We want to eliminate one variable. Let's eliminate z. How? Let's take the equation 2 and 3. So we have 2x plus, we can choose any two of the equations. So this is 2, and x plus y plus z equals 2. This is the third equation. Now we try to eliminate z. As you can see, I chose 2 and 3 because it's very easy to eliminate z. We have z and negative z, and if we add the two equations, we get 3x plus 2y, this is 0, equals 4. So we got a new equation, 4. Now this equation includes x and y. Now we need another equation that includes x and y in order to solve the system as we did in the previous examples. So we didn't use the first equation. So let's use 1 and 2, the one that we didn't use, and we can use it with any of the other two equations. to get an equation of the variables x and y. So the first equation is 3x plus 9y plus 6z equals 3, and the second one is 2x plus y minus z equals 2. Now we want to eliminate z. Now how to eliminate z? We need to get rid of z by multiplying the second equation by 6. If we multiply the second equation by 6, that means we multiply negative z by 6, it becomes negative z, and in the above equation 1, we have 6z, that's 0. So let's multiply the second equation by positive 6. Now we get the following system. The first one, we didn't change anything on the first equation. The second equation becomes 6 times 2x is 12x. We should multiply each term of the equation by that 6. 6 times y is 6y. 6 times negative z, negative 6z. 6 times 2, 12. This is the second equation. Now we can add. 3x plus 12x is 15x. 9y plus 6y is 15y. And negative 6x z and plus 6z is 0, and on the right hand side we have 15. So we divide each term by 15, we get x plus y equals 1. This is equation 5. Now since equations 4 and 5 have same variables x and y, we can solve for x or for y. I mean, we can solve this system by using either elimination method or substitution method. So we consider the systems, take 4 and 5 and solve them simultaneously. So number 4 is 3x plus 2y equals 4, and number 5 is x plus y equals 1. This is 4, this is 5. Now we want to eliminate x or y, so if we multiply the second one, let's eliminate y. To eliminate y, we can eliminate either x or y, but let's eliminate y. We multiply, we need this to be negative 2y, so we multiply by negative 2, the equation 5. This becomes, the first equation is still the same, I mean equation 4, and 5 becomes negative 6x minus 2y equals negative 2. This is number 5, and then we add them, we get negative 3x. Oh, here this is just, I multiplied negative 2 by x, it's just negative 2x. Now 3x minus 2x is just x, and here this is 0, negative 2y plus 2y, and on the right hand side 4 minus 2 is 2, so we got a value of x. Now we need to find y. Y can be obtained from, for example, equation 5 by plugging x equals 2. So we have 2. In order to find y, we substitute in 5, so x is 2 plus y equals 1. That means y equals negative 1. So x equals 2, y equals negative 1. Now we need to find z. We can use any of the equations here. So let's use the third equation because it looks simpler, the simpler equation. So equation 3 gives x plus y plus z equals 2. X is 2, y is negative 1, and z, we don't know z, so this is 1 plus z equals 2, and then bring this to the right hand side or subtract 1 from both sides, you get z equals 1. So the solution is x, y, z, x, y, and z. X is 2, y is negative 1, and z is 1. So we got one solution which consists of x, a value of x, a value of y, and a value of z. So this is consistent. The system is consistent, and we have only one solution.